So this video will be just a small recap on the intermediate value property and one example regarding this property. So we talked about the intermediate value property, right? So IVP basically suggests that if there is a function f and it turns out to be continuous in the closed interval AB, right? And this is very important to consider at this point, that the interval AB is closed and it's not open, because if it were like open, it would be a totally different situation, because it wouldn't attain a minimum and a maximum in an open interval. It would do so only in a closed interval, right? So if this holds true, then f attains every value that there is between fa and fp. And we talked about the polynomial example in the previous video, and there was a polynomial and there seemed to be a jump. We were trying to determine if it intersected the x-axis, if there was a zero that existed, right? So in an attempt to do that, we figured out that the function values were -2 and 4 for -1 and +1, right? So p of -1 gave me that and p of +1 gave me that. Since the function is polynomial, and we know that polynomials are continuous everywhere, right? Except when it's a rational function, but that's a specific case. So if there's a jump from -2 to 4, there has to be a value where p of x equals 0, which means it intersects the x-axis. So the intermediate value property is very much applicable over here, right? So another example that we should go through is one of a step function. We talked about it in the previous lecture, but not in too much detail. Value -1 is attained for all x values less than 0, and a value of +1 is attained for all x greater than 0. So we now note that if we try to calculate f of -1, that f of -1 implies that -1 lies in the range x is less than or equal to 0, right? So we're going to use -1, and our answer turns out to be that. And if we use f of +1, if we want to calculate that, we know that for all positive values of x, we use the +1 function. So in this piecewise function, +1 is going to be picked. So these are the two functions that we're considering, right? So the idea is that f does not attain any other values on this interval except these two values. So if we consider the interval -1 to +1, we have -1, right? If we have -0.5, it's still going to be -1, right? So if you were to draw a graph like the previous cases, we'd get something similar to this. So that's for x is less than 0 or less or equal to 0 as well, right? And that's for x is greater than 0. So what happens is there's a jump between that, and the idea is that the intermediate value property can be applied over here, because f attains every possible value between fa and fp. We might think that the intermediate value property is being violated over here or being contradicted, but that is not the case, because if you look at this situation and analyze it, we have a value of -1 over here, right? We have a constant function, and a value of -1 is attained, right? And then there's this jump to a value of +1, but there's no other value in the middle. The function is defined as such to cater for all possible values of x. So there's x is less than 0, x is equal to 0, and x is greater than 0. Luckily, these two cases are taken care of in this function, and the other case is taken care of in this function, due to which we can apply the intermediate value theorem over here for this specific function. It's a piecewise function. It's a step function, actually. It's different, but the intermediate value property can still be applied over here. So that's pretty much it for this section. In the next section, we're going to be starting something different, and hopefully we'll be talking about tangent lines and slopes and how we can express the average rate of change. And it's going to be a very interesting section, so I hope you guys stick to these lectures, and we see you guys in the next section, and I really hope that you guys are enjoying the videos. See you guys.